I'm Sarah Ballesteros.
And I'm Lily Dieters.
And today we will be presenting our final project for CS2316.
We wanted to explore tobacco use across the United States, and this is a quick overview of our presentation.
The purpose of our presentation was to examine the relationship between tobacco use, tax revenue, and lung cancer rates in the U.S. By analyzing data on these topics, we wanted to identify patterns that might suggest the dangers of tobacco use in relation to lung cancer and look at how tobacco use influences tax revenue or vice versa. We were interested in this because of the shifting use of tobacco in recent years, along with our knowledge of tax policy and health risks associated with tobacco use.
Our points of interest were the health risks of tobacco use, impact of tobacco taxation, and how tobacco use varies across the United States. And we chose our data sets to explore the dangers of tobacco use and the cancerous effects tobacco use has on Americans. We expected to find a positive correlation between lung cancer incidence rates, the percentage of daily consumption of tobacco products, and tobacco tax revenue, as we know that tobacco products are carcinogenic.
So our data collection process, for the downloaded dataset, we used data.gov to search for datasets about tobacco use and found a CDC dataset that had information about varying demographics, states, and types of tobacco use. For the HTML, we found a website on CDC that was scrapable and had a data table that included information about lung cancer incidence rates, cases, and trends at the US state level. And for our JSON API, we found a page on the CDC that had a data set with an API endpoint. We had the obstacle that the API had a limit of 1,000 rows per request, so we used a loop to overcome this challenge.
To clean our CSV, we read the downloaded CSV file into a data frame and removed columns unnecessary for our analysis. We cleaned a year inconsistency as we adjusted rows with a 2-year range instead of 1-year range to display the year the survey began to create a more consistent column of years using .apply with a lambda function. We then dropped rows with NaN data values and utilized drop_NA to keep only rows containing data, and we created an additional column with data values as floats instead of percentages.
For the HTML, we used Beautiful Soup to parse through the data and find the table we wanted. We then extracted the headers and we created a list to store the clean data. We cleaned the data using functions clean text and fix num, which we defined. Clean text stripped the white space and removed unneeded parenthetical text using regular expressions, and we handled NA and asterisk values, converting them to defaults.
And fix num converted text to numeric data types and removed ranges and commas to facilitate numeric conversion using regex. We then wrote the clean data to a CSV using CSV Writer.
For our API JSON, we set the base URL of our API endpoint with the parameters for the rows to fetch, the limit, and offset. The while loop helped us fetch requests to get all of the rows via 1,000 row chunks because of the limit. Then we stored this data in a list, converting it to a data frame. We dropped unneeded columns. We did not have any inconsistencies in this data set.
For our first insight, we looked at how tobacco use and lung cancer differ regionally and how may tobacco taxation correlate. So to do this, we found the mean average annual count for lung cancer, the mean percentage of tobacco use, and the mean tobacco tax revenue by U.S. region. And we used group by, map, rename, merge, and sort values. Our results were, while the South has the highest cancer count, tobacco use appears steady across all regions, and tobacco tax revenue is the highest in the Northeast. The revenue trend could be caused by the higher overall tax rates in the Northeast, and there is no clear conclusion about a strong correlation between the three factors.
For our second insight and first visualization, we wanted to look at if there was a correlation between changes in tobacco use and tobacco tax revenue over time. We found mean tobacco use percentages and mean tax revenue across all states for each year from 2011 and after using group by and .mean. We merged these resulting series using merge to easily compare all the data in a data frame joined by year. So we wanted to analyze the correlation between the use and the tax revenue over time to see if the changes might point to changes in tobacco use. While tobacco use decreased from 2011 to 2016, an increase begins following that year. However, revenue fluctuated, which can indicate outside influencing forces such as tax law and industry practice. As seen in several sections of the chart, revenue and usage seem to have a somewhat positive correlation in certain time periods. This might indicate that increased tax revenue points to an increased consumption in tobacco purchases, rather than higher taxation leading to decreased tobacco use. We used matplotlib and its .plot function to plot two lines with different y values onto the same line graph using the columns of our merged data frame.
For Insight 3 and Data Visualization 2, we looked at if there was a correlation between smoking and lung cancer rates across the United States. And to do this, we filtered data in a clean data set to only look at the data for current smokers. We found the most recent year for each state, used merge to keep the rows with the most recent year for each state. We used group by to organize the data frame by state and find the mean percentage of current smokers per state. And we used .merge to combine lung cancer and smoking data frames by state. And our results showed that the states with higher percentages of smokers oftentimes also exhibit a higher rate of lung cancer. This points to a positive correlation between the two factors. We can see a positive correlation between the percentage of current smokers and the lung cancer incidence rate. Each data point represents one state despite a few outliers. There is a strong line of regression pointing to a positive correlation between the two events. We utilized matplotlib and Seaborn to create a scatterplot figure of our merged data frame. We included the regplot function to add a line of regression to better show the correlation.
For our fourth insight and third visualization, we wanted to look at how tobacco use differs among various demographics. We used group by to group the data by race and tobacco type, and we calculated the mean tobacco use percentage with .mean. With unstack, we then reshaped our multi-index series to a data frame with the tobacco types as columns and racial groups as rows. For the results, we wanted to use this data to determine how culture might impact tobacco use and health. E-cigarettes and smokeless tobacco use was relatively consistent. However, there was a disparity with cigarette use where Asian and Pacific Islander Americans consumed the least and African Americans consumed the most. For the visualization, we used matplotlib to create a grouped bar chart using subplots and bar, and we wanted to do this to compare the mean tobacco use percentages across the demographics. Each bar represented a different racial group studied. For the results, you can see here the disparities and the consistencies with the e-cigarette tobacco use and the smokeless tobacco. It's notable that, as we can see here, African Americans had the highest use and Asian and Pacific Islander Americans had the lowest use of cigarettes.
For Insight 5, we looked at which states rank the highest for each category we're analyzing in our data sets, and if some states are more problematic for tobacco use than others. And to do this, we filtered tobacco use data set for each specific topic, and we found the mean value for each combination of state and topic using group by and mean. We used IDX max to create a data frame with the max value for each state and topic. We filtered the tobacco tax data set, found the mean value per state, and found the state with the max value using .sort values and indexing. We repeated similar process for relevant data in the lung cancer incidence. From Insight 5 show which states have significant values for each of the topics which we have been analyzing in various contexts. For example, West Virginia has the highest percentage of cigarette users, while Wyoming has the highest percentage of e-cigarette/smokeless tobacco users. It's interesting to note that the states with the highest percentages of tobacco users were not necessarily the states with the highest lung cancer rates. Since all data was from the same year and cancer can take time to develop, it's reasonable that the current states with the highest lung cancer rates may not align with the current states with the highest usage. This data is unable to show correlation between these topics.
So for our overall results, some obstacles that we learned from is that we learned to use the global keyword to manage scope. We improved our understanding about data reshaping techniques, specifically with the unstack function. We learned to manage large API requests. Also, with our results, we saw significant regional and demographic differences and a positive correlation between tobacco use and lung cancer incidence. We also found that there was not a strong correlation between tobacco tax revenue and use. These findings highlight the importance of tobacco awareness and education, as region and race might influence tobacco consumption, which is proven to be related to lung cancer. Thank you for listening to our presentation.